Hello, welcome to Electrical Engineering 303, Signals and Systems at Cal State San Marcos. I'm Jerry Pinter, your instructor for the course. I'd like to take this opportunity to personally reach out and welcome you to my course. Please sit back and watch this short video where I'll explain everything you need to know and do to be successful in this course. Don't hesitate to reach out to me if you have any questions, comments, or concerns, or just want to say hi and chat. My contact info will be given in this lecture. You can also arrange to meet with me in person on campus if you wish. Thank you. Welcome again to EE 303. This is your instructor, Mr. Jerry Pinter, and in this short video, I will give you some information about the course. Just to clear up any confusion about the name of the course, this course was previously called Physics 403. That was the original name. And that was then changed to Physics 303, and now I'm proud to announce that the course is called EE 303. In all cases, these three names refer to the same course. Let me just give you a brief introduction to myself. I don't want to bore you with a lot of details, but I'm an electrical engineer. I went to school at University of Illinois for undergrad, and I went to grad school out here in California at UC San Diego. I spent 17 years in the semiconductor industry working on research, development, and manufacturing of semiconductor integrated circuits. I worked at Hughes Aircraft Center in Carlsbad, California, and then also Applied Microcircuits Corporation, AMCC, also in San Diego here in California. And I retired about 20 years ago in 2002, and for the past 20 years I've been here at Cal State San Marcos teaching physics, astronomy, and now more recently electrical engineering. Let me give you a little information about the course from our syllabus. The full syllabus is found on Canvas, and obviously this is for spring 2023, and this course this spring is online and asynchronous, and so I'll explain what that means and what you need to do regarding that in this video. So I assume that you're familiar with Canvas. We recently underwent some changes from Cougar Courses, the Moodle software, to now we're using Canvas, and you know, I'm still learning a few ins and outs of Canvas, and you may be as well, but our course page is on Canvas, and that's where you're going to find the lecture notes are all posted there, the syllabus, all homework is posted on Canvas, including the assignments where you turn in homework and so forth. There is a container or module that contains activities. Some of them are simulation software and things like that. And then later in the course, we'll be talking more about the final project, and that project information is on Canvas too. And any other course information that is needed will be posted on Canvas. So that's sort of your center point to where to find information for the course. We also have a YouTube channel, which I will explain in this video. It's called CSUSM EE 303, and that's where you're going to be watching my video lectures for the course. So I will talk about this more in detail shortly. I have office hours, but basically if you have any questions or comments, just send me an email. I will check my email daily and usually almost always get back to you within 24 hours. If you email something in the evening, I probably won't read it until the next day, so don't plan on getting a response, you know, that same night. I am on campus for another class, and I will be available for in-person office hours on Monday and Wednesday from 11:30 to 12:30, and that's in the Viasat Engineering Pavilion, room 5109. But please, if you want to see me in person, please send me an email and let's set up an appointment. I won't be waiting in my office or in this classroom if nobody is there. This is my email, which you probably already know, but that's where to contact me. And now let me just talk real briefly about the textbook. We're using a classic textbook. It's called Signals and Systems. It's by Oppenheim and Wilski. And we're using the second edition, which is the latest edition. Even though, you know, they haven't made another edition recently, this edition is still up to date on the theory of signals and systems. Interestingly, I used the same textbook back in the 1980s, which I realize was a long time ago for you guys. But when I was an undergraduate at Illinois, we used this same book. The first edition was out then. So it is a classic book that has stood the test of time, and you know, it's considered the top book for undergraduate signals and systems courses, and so that's why we're using it. Regarding the book, you know, you have several options. You can, you know, purchase a new book if you want to from the bookstore or from Amazon, but as you probably know, new books are extremely expensive. And if you want a new book, that's great, but you have other options. You can find paperback versions used on Amazon for around $20, and I've seen them used versions on, for example, Barnes & Noble. You may have some other website, you know, online book sellers or whatever to find used textbooks. And there are also rent and buyback options that you can get from various sellers. So find a copy of the textbook somewhere. It's a, you know, as I mentioned, it's a classic textbook that you probably will want to have on your bookshelf if you're going to be an electrical engineer working in the industry. So the course description for this class is an introduction to continuous time and discrete time signals, signal processing, and linear systems. The emphasis will be on electronic signals and systems, since most of you in this class are EE majors, but there are some examples that we will look at for other types of systems, such as mechanical systems and so forth. The course will include fundamentals of Fourier analysis, Fourier transforms, filter design, sampling theory, communication systems, Laplace transforms, Z transforms, and feedback and control systems. The prerequisite for the course, which I assume you have satisfied the prereq, it's Physics 202. However, Math 346, which is the mathematical methods course, and Physics 280, or you probably took EE 280, is highly recommended because we are going to be dealing with LCR type circuits, and we're going to be using differential equations, so that's where the math is going to come in here. So if you haven't had Math 346, you know, you will learn how to do differential equations in this course, but it'll be, you know, much easier for you if you've already had that material. So here's our tentative course schedule. And I won't read through all the details here, but basically I do want to point out here the textbook, as you can see for the textbook chapters, we are going to cover the textbook from chapter 1 all the way through to the end of the textbook, chapter 11, in order and in sequence, which is kind of nice. We won't be skipping around like some courses do. But the other thing I want to emphasize here is that we are covering the entire textbook, which is quite a bit of material. So we will be picking and choosing various topics in each of the chapters. And so my philosophy here for this course is to offer a lot of breadth and not that much depth. So in other words, we're going to cover a lot of topics, but not go super deep into them. But you're going to learn all the essentials and basics and fundamentals of signals and systems by covering this whole book. Regarding your course grade, and again, the syllabus will have more details on this, but basically the vast majority of your grade is going to be the homework that you're going to submit online. And this is in the form of worksheets, which contain problems, textbook type problems, and also hands-on activities with a lab kit that you're going to use. And I'll have more details on that as well. But as you can see, this is the bulk of your course grade. So that's where you really need to spend your effort and time, is on these worksheets. There's also a filter design project, sort of a final project for the course, and that will be the remaining 20% of your grade. And I'll talk more about that later. We don't need to get into the details of that right now. There is also some extra credit opportunities in terms of extra credit homework assignments that will be posted in the homework section. So the good news here, obviously, is that this course has no midterm exams and there's no final exam for the course. So I think you can all appreciate that. So let's now go over how you'll be watching the video lectures. And the video lectures are online on YouTube. So as I mentioned, and as you know, this course is asynchronous, and that means you can watch the pre-recorded video lectures for each chapter at any time of day or night at your own convenience, and you can watch them as many times as you want. The video lectures contain the exact same material, content, examples, and demonstrations and experiments that I would use in the classroom. So my point here is that even though this course is remote learning, it's online, it's asynchronous, you're not missing out on anything. You will get the full content and full material scope of this course just like we were in the classroom. So lecture notes, in addition to being on YouTube, which I will explain shortly, they're also posted on Canvas. And the ones on Canvas are just the PowerPoint slides without my narration, and it won't have any video demonstrations if there are any. But these PowerPoint slides are useful for review. You know, once you watch the video, you may want to go back and just look at the slides without my talking and so forth. But I would strongly recommend that you always start each chapter by watching the YouTube video lectures, because I do a lot of explaining and things like that for those lectures. Another thing about this course that maybe is a little bit different from other asynchronous courses is that there's no attendance and there's no roll call taken. There is no live Zoom sessions where I'm going to be taking attendance and so forth. So it's completely up to you to watch the lectures, take notes, etc., and prepare yourself for each homework assignment worksheet. Now, even though the course is asynchronous, the homework worksheets, which remember are the bulk of your grade, they do have due dates, and the due dates are firm. So be sure to keep up and watch the video lectures for each chapter well before the due dates so that you can finish the worksheets on time. If the worksheets are submitted late, they will be penalized fairly stiffly for being late. So my warning here is just get the worksheets done on time so that you get full credit for your work. But I will mention that these worksheets will take considerable effort. Some of them are even broken up into 2 parts because of their length. And the idea here again is, remember, you're not going to be doing any exams or taking any exams on this material. So all the effort and time is going to be put into these worksheets. So where are these video lectures? Well, they're on my public YouTube channel, which is called CSUSM EE303, and I will explain that next. So here's how to find the online YouTube video lectures. You go to YouTube, www.youtube.com, and there's a YouTube search bar. So enter our channel name, which is CSUSM EE303, and you'll see somewhere in the list of hits that come up our icon for our course. It's this blue circle with a C in it, and it says CSUSM EE303. So if you click on this icon here on YouTube, you will enter into the channel, and you're going to see a page that looks something like this at the top of the page. So what you're going to do here is click on the Videos tab right here, and that should open up all the videos for the course. And there are lots of them. There are over 40 or even maybe over 45 videos that I've prepared. And the order of them is a little bit random. I think it may have to do with the order that they were uploaded onto YouTube. Unfortunately, I don't know a way to put them in proper sequence. So you sometimes might have to fish around for them a little bit. Scroll down to find the first video lecture. After you watch this video, the first lecture is called Chapter 1, Part 1, Introduction to Signals and Systems. So that's going to be the first lecture, and again, you can watch this video anytime because the course is asynchronous. note that the chapter videos are almost always broken up into several parts due to the length of each chapter. So for example, chapter 4 has 4 parts. So be sure to watch all parts of each video before doing the worksheet for the chapter. And the worksheets are found on Canvas, and more about that later. As I mentioned previously, the lecture notes are also posted on Canvas without the video animations and without my voice narrating. And again, use those for review only. I would always recommend starting with the video lectures on YouTube so that you don't miss any of the content. So this is maybe the most important slide of information in this lecture. This tells you basically what you have to do and when you have to do it. So this is our lecture and worksheet schedule. And as I've said several times now, this course is asynchronous, meaning that you can watch the lectures and do the worksheets at any time as long as you do them before the posted due date. So this schedule here is shown in the syllabus. It's shown here, obviously. It's also shown on Canvas, and you can refer to it. But it basically shows the sequence of video lectures that you're going to watch and the worksheets that are associated with those lectures, and most important here is the due date when you have to submit these by on Canvas. And these due dates, by the way, are also found on Canvas in the assignment section. Each one of these worksheets is posted as an assignment, and you'll be submitting it there by that due date. So for example, we're starting here, I'm just calling this chapter 0. This is our welcome to EE 303 Signals and Systems, and where you're going to start the course is for chapter 1. You're going to do the Introduction to Signals and Systems videos, and again, there are 4 videos, so there are going to be part 1, 2, 3, and 4, so you'll watch 4 separate YouTube videos, and then you can download the worksheet off of Canvas, do the worksheet, do the activities on there and so forth, and write it up, and then you're going to submit it on Canvas by February 8th for full credit. And after you do that, you just go and you keep going. The next one is chapter 2, which is called LTI Systems. That chapter is broken up into 5 different videos, parts 1, 2, 3, 4, and 5. And after you watch all those, you can start working on worksheet number 2, which is due on February 22nd. And so you're just going to repeat this process for each chapter. And the only other thing I'll point out here is when we get to chapter 4, worksheet number 4 is a bit longer, so it's broken up into 2 pieces. So it actually counts as 2 assignments on Canvas, and you'll have to do part 1 worksheet, submit it, and then do part 2 of the worksheet and submit that. And as you can see, that's not due until March. And then later on down in the course, worksheets 9 and 10 are also 2-part worksheets. And that pretty much, these 11 worksheets here pretty much takes care of most of your grade for the course. As I mentioned, that's 80% of your course grade. The only other thing that we'll be working on later into the course, when we get more of the material under our belts and so forth, is the filter design project. And so we'll talk about that when the time comes later on in the course. Just a reminder again, this course has no midterm exams and there's no final exam, so that's nice. And just again, sort of a warning, the worksheets require considerable effort. And the reason is they include textbook problems, sometimes they'll have computer simulations, and they will also have, many of them have hands-on laboratory activities using your lab kit. So speaking of the lab kit, one of the key components in your lab kit is the AD2, which stands for Analog Discovery 2 kit. And the AD2 is a portable instrument that turns your computer into a complete electronics lab. It's a really nifty device. This is what it looks like here, and you can see it connects with just a simple USB cable to your computer, and it'll turn your computer into a whole multitude of electronic instruments. So it has a lot of functions that we're going to be using. There are many more that we won't be using, but the ones that are most important for us in this course, it has a 2-channel oscilloscope. That's sort of what you see here with the waveform and so forth. It has a waveform or signal generator built into it, so you can make your own sine waves, square waves, and so forth, pulses. It contains a power supply that you can run a circuit, such as your filter. It has a built-in voltmeter, and then it has some more advanced functions such as a network analyzer, and it allows us to do spectrum analysis. So you'll be getting introduced to all of these various functions as you work through the worksheets. So the 82 is going to be used for homework activities right off the bat. You'll be doing some hands-on laboratory type experiments at home. Again, this is the beauty of this class, is because it's asynchronous, you can work on these experiments and hands-on activities in your home or in your apartment or dorm room, wherever you are. All you need is your computer, and you will have a lab kit with all the necessary parts. And also you're going to use it for your filter project. You're going to design, build, and analyze and test your filter using the 82 and other equipment that's in your lab kit. So on Canvas, there is a module called Analog Discovery Instructions, and that's something that you can look at right away because you have to download some software for the 82. You have to download the software on your computer so that it can run it. So here's a summary of what I've just talked about and what you need to do right off the bat here to get started with the course. So the first thing is find a copy of the textbook. We talked about all the various options there. The next thing is to pick up your EE303 lab kit on campus. And I'll have more information on that as to the dates and the times when you can come in and pick up your kit. But the kit includes the analog discovery kit, the 82 device that we just talked about, and all the other components and supplies. It has breadboards and wires and so forth. So everything that you'll need to do the lab activities is in that lab kit, which you will check out at the beginning of the semester. You'll keep it at home. You can bring it into school with you if you want, but you're responsible for it, and you'll return it at the end of the semester. The next thing is, as I explained, you're going to watch video lectures on our YouTube channel, and after the video lectures, you will work on the worksheet, activities, and problems. And as mentioned, some of those activities are hands-on experiments using your lab kit. You'll submit your worksheets on Canvas in the assignment section by the due date, and those due dates, again, are firm. If you miss a due date, you can still submit things, but they will be marked off with penalty points for being late. And then later in the semester, we'll talk about the final project, which is the filter design project. That's not something you have to worry about right now, but we'll get into that later. So basically, these steps 3, 4, and 5, you're just going to repeat each of these steps for each chapter of the course, starting with chapter 1, and going all the way up through chapter 11. I'd like to just finish here with a word of caution for this course, especially since this course is asynchronous. Sometimes students might think, oh, well, this is going to be kind of easy. I don't even have to go into class. I can just, do this stuff at home. A lot of students find that Signals and Systems is one of the most challenging courses that they take in the curriculum. And the reason for this is there are several complex and very abstract topics. For example, we've got differential equations and a technique called convolution, which it sounds like the word convoluted, and it is. It's kind of tedious and a headache and a little bit confusing. We're going to be working not only with continuous time signals and systems, which make a little more sense intuitively, but also discrete time analysis, which sort of leads to the idea of digital signals and systems. most of the time we're going to be working not in the time domain, but in the frequency domain, and we'll be using transforms such as Fourier transforms, Laplace transforms, and Z transforms. And so, all of this frequency domain work and these transforms make the course very mathematically intense. And so, be careful, when you're watching the videos, pause and replay the video if necessary. If something kind of went over your head or you were distracted or whatever, that's one of the beauties of the asynchronous type of course here, is that you can just pause the video, you can go back and listen to it again, and make sure you're absorbing and understanding and comprehending all the material before you move on to the next topic in the lecture. That'll help greatly. And then also in my lectures, I have activities like practice problems for you to do. And obviously, this is just honor system. I don't know if you're doing them or not, and that's completely up to you. But I would highly recommend that you pause the video when I mention it and see if you can do the activity or the problem that is shown. And then I'll show you the solutions as well. So this is a way to sort of keep up and check your work and make sure that you're really understanding the concepts before we move on to the next topics. The other thing to keep in mind here is to keep up with the scheduled lectures and worksheets. Don't fall behind in this course. Because of the difficulty of the course, if you fall behind, it's going to be very hard to catch up. And I think as engineering majors and students, I don't need to remind you of that. You're used to that type of rigor and so forth, but it does take discipline to do well in a course like this. Let's see. So basically, if you do all this, if you can keep up and put in the effort and so forth, I guarantee that you're going to learn a lot about signals and systems theory and also how to apply it practically. So with no further words, let's get started, and I will see you in Chapter 1, Part 1. Until then, take care and thank you. Goodbye.